So my name is Leah Talbert, and I teach earth science, and this is
Maribeth Lowe, and I teach earth science as well as special education.
And we've been co-teaching together for about 7 years. And our co-teaching model is exactly what it sounds like. It's co-teaching.
Mm-hmm.
There may be times when in a lesson, like what you would see in the video, that we actually share the teaching responsibilities. I might be up at the front one time during the lesson, and then Maribeth comes up to the front and does the lesson while I monitor, and vice versa. And there's other times when we split up the pacing guide and say, I'm going to take the first chapter and you do the next chapter.
Right.
And again, the monitoring is happening by the other teacher, or whatever the activity may be. It might be
Right.
that there's some student-led activities that need both of us monitoring around.
Right, and we always have students in our class who, of course with IEPs, who may have special accommodations, and we make sure that those accommodations happen, like for testing.
Right.
We take turns. Just because I'm the special education teacher
Right.
doesn't mean that I always take the students out for read aloud or for any extra help. That can also happen. Leah can do that. We completely share those responsibilities on both the students who do not have IEPs as well as students who do.
Right. I don't know that we've ever even said to our kids which one of us is the gen ed teacher and which one is the special ed. We're
No.
just their teachers.
Right.
And it's all the way. I mean, both of our names are on the syllabus, both of our names are on the door, names are on the schedules.
Right.
So
I think our goal as co-teachers, and for us anyway, co-teaching means that if you were to come into our classroom on any given day and you didn't know us, you wouldn't necessarily know who was the general ed teacher and who was the special educator.
All right, so let's look at that bell ringer together, and let's go over the buzzwords that are associated with igneous rock. Okay, who can raise their hand and tell me one of the ones you circled? Okay. Magma and lava. You didn't circle that one. Circle it. Okay, Troy?
From fire.
From fire, yeah. That's what that word means. Like you've heard the word ignite. Igneous from fire. Intrusive and extrusive. And that's really what we're going to focus on today. And then we got one more, Logan.
Volcanic rock.
Volcanic rock. Okay, up here
Is we're going to make a prediction about whether the following rocks are intrusive and extrusive. Now you notice that we don't have a name for the rocks. So what are we going to base whether they're intrusive and extrusive on right now on the picture? What they look like? What are we looking at specifically?
Crystal size.
Crystal size. We're looking at the crystals. So we're going to make a prediction about whether the following rocks are intrusive and extrusive, and then we're going to slide it across to see if we have the right answer. So do I have a volunteer to come up and make a prediction? Come on, somebody. Yes, please. Somebody. All right. Ms. Talbert gets to pick someone.
All right, I'm going to just pick someone closest to the front. And Sarah, if you, I don't know. Thank you. Then you get to choose someone as no one volunteers, remember.
Okay, so all you're going to do is you're going to look at this rock and you're going to circle whether it's intrusive or extrusive based on what it looks like. And you can think out loud if you need to. What do you see on it? Large crystals, so which is it, intrusive or extrusive? Yes. Okay, so choose a pointer up here. And then what she's going to do is she's going to slide the rock across to see if she's correct. Very good. It is intrusive, and she said it was because of the listen. So this is what you're going to do. Hi, let's put it down. This is what you're going to do. You've seen these rocks before. You should have in your box, open up your box again. You should have in your box, you should have a piece of chalk. So what we want you to do on your desk, on your table, is you're going to draw a T-chart. You're going to draw a T-chart. Make it big enough so everyone can see. You're going to be making it in the middle of the table. Make a T-chart, and Ms. Talbert's putting it up here. And on one side of your T-chart is intrusive, and you can abbreviate I or INT. and the other side is extrusive. Now, all we've talked about so far is we've talked about crystal size and how the rocks look, right? So what I want you to do in your group is I want you to look at each of the rocks in your box and decide, just by looking at it, whether it's intrusive or extrusive.
And work together.
Yeah, work together.
Everybody's got at least one partner.
And kind of make some decisions. If you're not sure, raise your hand and you can ask.
You don't have to write it out, guys. You just have to place the rock in it. Don't identify the rock, just place it in there.
Actually, it does look like it, but actually which is
What makes you put these right here? Well, they're very similar, but they are actually two different rocks. This is a granite and
by
white
the same
granite.
token, I think it's important that when people come into the classroom that they not be able to tell which students in the
Right.
classroom have IEPs and which do not. And so with the way we teach, I think that we do a really good job of keeping it really focused on the learning, and you're not able to tell on any given day who is the general ed teacher, who's the special ed teacher, who's the student with special needs, who's the student who perhaps is advanced. You just don't, we try to give the same content to each. That being said, we know there are students that we need to key in on, and we
Right.
know that there are students who need extra help. And the teacher who is monitoring, whoever that person is,
Right.
is usually the person who is making sure that they're hitting those students who need the extra help. through the
Basically
lesson.
what you just did, we've got some rocks up here, we're gonna make predictions, just like we did as kind of a class, and then we'll check our answers. So Sarah, you were up last. Does anybody want to come up this time? Okay, Haley, why don't you come on up? To make a prediction, Haley, what you're gonna do is these are closed here at the bottom, so you just wanna grab one and pull it. Okay, and then wait to slide it. Okay, so why don't you make us a prediction, and you can choose whichever one you would like.
Hard to see, yeah.
Okay. All right. And so what you want to do, she says this one's extrusive. So by saying extrusive, is that coarse grained or fine grained? Fine grained. Good. Okay. So then grab your rock and slide it over.
Good job.
Okay. Somebody new?
All right, so I'll read this because it's a little small, but you can look at the pictures, you can probably see those. The texture of igneous rocks is determined by how quickly the liquid rock cools. The slower the cooling rate, the larger the crystals in the rock. Two igneous rocks can have similar mineral composition, as is true with these rocks, even if they have very different textures. Based on their textures, the rhyolite here cooled slowly, and the granite here cooled quickly. True or false? Rhyolite cooled slowly, granite cooled quickly. True or false? Who do we have here?
We're only going to send one, so
Yeah.
it should be 23.
Okay, so what should it be?
True.
All right, let's
Let's look
before
at
we
it.
answer it, let's go back and look at it.
Listen what it says. The slower the cooling rate, the larger the crystals in the rock. So which one of these has the larger crystals? The left, or your left, or the right? The right. So which one of these cooled more slowly?
Right.
The right.
It's false.
Okay, so it should be false.
That was correct.
Good job.
All right, let's see how we did on that.
Okay, so we're
Half and
split.
half. We need to think about it, okay?
He did
So
that.
here's the thing. Since the rhyolite has smaller crystals, and this is the rhyolite, it has almost no crystals, you can see. Since the rhyolite has smaller crystals, one can infer that it cooled quickly and the granite cooled slowly, creating larger crystals. So those of you who said that the rhyolite cooled slowly, do you understand now why the granite is the one that cooled slowly? What does the granite have that the rhyolite does not? Crystals that you can actually see. Okay?
So that's what we believe in, co-teaching.
And that's our motto.
Holla.